Every shower in America is secretly throwing heat down the drain. Not water, heat. The same energy your water heater just spent money creating. The same heat that came from electricity, natural gas, propane, or whatever fuel your house uses to make a cold morning shower feel human. It rushes across your shoulders. It disappears into the drain, and seconds later, it is gone. Most homeowners never think about it because the shower feels like a water problem. Turn the handle, wait for hot water, step in, use it, lose it. But inside the wall, beneath the tub, or somewhere below the bathroom floor, something expensive is happening. Hot water is falling down a pipe. Cold water is coming into the house. And those two streams pass through the building like strangers, one carrying energy away, one demanding new energy from the water heater. The strange part is this: they do not have to stay strangers. With one vertical copper heat exchanger, part of that lost heat can be stolen back before the water heater ever works for it again. No motor, no compressor, no refrigerant, no battery, no software, just gravity, copper, and a simple truth most homes ignore. Warm drain water still has value. This is the story of the pipe that steals heat from your shower drain. And once you understand how it works, every hot shower will start to look like a small energy leak hiding in plain sight. Here is the part most people miss. Your water heater is not only heating water, it is constantly replacing heat you just threw away. The Department of Energy says water heating accounts for about 18% of home energy use and is typically the second largest energy expense in a home. That means hot water is not a minor comfort. It is one of the major energy systems inside the American house. Showers, dishwashers, sinks, laundry. Every time hot water leaves the tank, the house has to bring cold water back in. And that cold water is not starting from room temperature. In many parts of America, the water entering the house can be shockingly cold. It has been sitting underground, moving through buried pipes, carrying the temperature of the soil, the season, and the region. In Minnesota, that incoming water can be brutally cold in winter. In Michigan, Wisconsin, Maine, or upstate New York, it can enter the home far below what a shower needs. Even in warmer states, the water heater still has to lift that incoming water to a usable temperature. That temperature lift is the cost. The colder the incoming water, the harder the water heater works. Now picture a normal shower. Hot water leaves the water heater. It travels to the bathroom. It comes out of the shower head. It touches your body for a few seconds. Then it falls directly into the drain. But when that water enters the drain, it is not cold. It is still warm. It may no longer be useful as clean shower water, but thermally, it still carries a large amount of energy. And in a conventional house, that energy is simply dumped into the plumbing system. The house paid to heat the water. The person used it for a moment. Then, the heat was abandoned. This is the hidden waste, not the water itself, the temperature, the energy inside the water. And the reason this waste is so easy to ignore is because it happens invisibly. You do not see heat leaving the house. You only see water disappearing. But physics does not care what you notice. Heat is still heat. Energy is still energy. And warm drain water is still a moving stream of value leaving the building. This is where drain water heat recovery enters the story. The Department of Energy describes these systems as devices that recover heat from hot water used in showers, bathtubs, sinks, dishwashers, and clothes washers. But the most common and practical version for a house is beautifully simple. It is usually a copper heat exchanger that replaces a vertical section of the main waste drain. Warm drain water flows down the inside of that vertical copper pipe. At the same time, incoming cold water flows through a copper coil wrapped tightly around the outside. The drain water never mixes with the clean water. That is the crucial point. This is not recycling dirty water. It is not sending shower water back into your faucet. It is not storing wastewater in some strange tank behind the wall. It is only moving heat. The warm drain water falls down one side of the copper. The clean, cold water moves through the other side. The copper wall transfers heat between them. By the time the cold water leaves the coil, it is no longer as cold as it was when it entered the house. It has been preheated. That preheated water can then go to the water heater, to the shower mixing valve, or to both, depending on the plumbing design. And that is where the energy savings begin, because the water heater no longer has to do the entire job from scratch. Instead of taking very cold incoming water and lifting it all the way to the storage temperature, it receives water that has already borrowed heat from the drain. The water heater still works, but it works less. And that difference is the recovered energy. This is why the shower is the perfect target. A dishwasher runs in cycles. A clothes washer fills, drains, and pauses. A sink may only run hot water briefly, but a shower creates exactly the condition a simple, non-storage heat recovery system wants. Hot drain water is flowing down. Cold supply water is flowing in. Both streams are moving at the same time. That simultaneous flow is the magic. Without storage, the system only has useful heat to recover when warm drain water and incoming cold water are moving together. That is why showers matter so much. A shower is one of the few moments in the house where the drain is losing heat. At the same time, the plumbing system is demanding new hot water. In other words, the waste and the need happen together. And when those two moments overlap, a simple copper pipe can connect them. Here is what makes the idea feel almost unfair. There are no moving parts, no electronic controls, no compressor cycling on and off, no fan pulling air, no pump forcing refrigerant through a loop. The drain water is already moving because of gravity. The cold water is already moving because someone opened the shower. The copper is already one of the best common materials for transferring heat. The system simply places those facts next to each other. That is it. The house is already creating the waste stream. The house is already bringing in cold water. The technology only asks one question. Why not let the two streams exchange heat before one leaves forever? This is the kind of building science that modern homeowners rarely hear about. Not because it is impossible, not because it requires futuristic materials, not because the physics is mysterious, but because it does not look like a typical upgrade. It is not a shiny appliance in the kitchen. It is not a smart thermostat on the wall. It is not a solar panel on the roof. It is not a massive outdoor unit humming beside the house. It is a copper section of pipe hidden in the mechanical space. And that makes it easy for the market to ignore. No one shows it off during a home tour. No one buys a house because the drain stack is impressive. No one posts a picture of a wastewater heat exchanger and says, "Look at my luxury remodel." But the physics does not need attention to work. The same is true for insulation, air sealing, pipe insulation, shading, ventilation. The best energy upgrades are often the least glamorous ones. They do not create comfort by looking expensive. They create comfort by stopping waste before it becomes normal. And drain water heat recovery does exactly that. It looks at one of the most common routines in American life, the hot shower, and finds a thermal mistake happening every morning. The mistake is not that people shower. The mistake is that the house treats warm drain water as worthless the moment it disappears below the floor. But that water is not worthless yet. It is dirty, yes. It is leaving, yes. But it is still warm. And for a few seconds before it disappears into the sewer line, it can give part of that warmth back. This is why the numbers matter. The Department of Energy lists typical purchase prices for drain water heat recovery systems at about $300 to $500. It also notes payback periods ranging from about 2.5 to 7 years, depending on how often the system is used and the temperature of the incoming water. That range is important. It means this is not magic. It is not automatically perfect for every house. A family that takes long showers every day may see a different result than a single person who barely uses hot water. A cold climate home with very cold incoming water may have a different opportunity than a warm climate home where the incoming water starts higher. A new build or major bathroom remodel may make installation easier than a finished house where the right vertical drain stack is buried behind walls. But the underlying principle is hard to argue with. If you already paid to heat the water and that water is still warm when it hits the drain, then the heat inside it is not gone yet. It is only being allowed to leave. And that is the hidden opportunity, not a new source of energy. A second chance at energy you already bought. So, before we talk about why this technology never became common in American homes, before we talk about plumbing codes, installation limits, vertical drain stacks, and why builders rarely mention it, you have to hold one image in your mind. A shower running upstairs, warm water falling down the drain, cold water entering the house at the same time, and between them, one copper pipe quietly asking the question, "Modern plumbing forgot." Why should heat leave the house without paying rent? So if the physics is this simple, why is this not already standard in every American house? That is where the story becomes more complicated. Because drain water heat recovery does not fail on physics. It fails on timing. It fails on plumbing layout. It fails on the way houses are built, financed, inspected, and sold. And, most of all, it fails because the best place to install it is often the exact place most homeowners never see. Behind the wall, below the bathroom, inside the mechanical space, on a vertical drain stack. That one detail changes everything. A drain water heat recovery unit works best when warm water flows down a vertical drain pipe in a thin film along the inside wall. Gravity spreads the warm wastewater across the copper surface. Cold, clean water wraps around the outside coil. The heat moves through the copper. But for that to happen efficiently, the system needs the right geometry. A vertical drop, enough pipe length, access to the drain line, access to the cold water supply, and a plumbing arrangement where the recovered heat can actually be used. That is easy to plan in a new house. It is easier during a major bathroom remodel. It can be practical when the shower drain drops straight into a basement or mechanical room. But in a finished house with closed walls, tight framing, short horizontal drain runs, slab foundations, and plumbing buried where no one can easily reach it, the economics can change fast. The pipe itself may cost a few $100s. The access can cost much more. That is the first reason this technology stays invisible. The part is simple. The house around it is not. A new water heater can be sold like a product. A heat pump water heater can be shown in a showroom. A tankless system has a brochure, a brand name, a digital display, and a clear replacement moment. But drain water heat recovery is different. It is not usually a standalone appliance that sits proudly in the garage. It is a plumbing detail, a piece of building infrastructure. It works best when someone thinks about it before the walls close. And American housing is not always good at rewarding invisible details. Here is the part most people miss. Builders are paid to complete the house. Homeowners are left to operate it. Those are two very different financial moments. A builder deciding on plumbing during construction is under pressure to control upfront cost. Every added component is another line item, another installation step, another possible inspection question, another product the crew may not already know, another detail that may not help sell the house faster. But the homeowner living there later is the person paying for water heating every month. The builder feels the cost immediately. The homeowner feels the savings slowly. That mismatch buries a lot of good building science. It buries better insulation. It buries air sealing. It buries better ducts. It buries thoughtful shading. And it buries a copper pipe that could recover heat from the shower drain, not because it does not work, because the person who has to pay for it is often not the person who benefits most from it. Now add the problem of visibility. A kitchen island sells a house. A tile shower sells a house. Quartz countertops sell a house. A drain water heat recovery pipe hidden near the waste stack does not sell a house emotionally. No buyer walks through a model home and says, "Look at that beautiful wastewater heat exchanger." No real estate listing says, "Includes elegant vertical copper drain recovery system." No family posts a picture of the mechanical room and gets excited about preheated inlet water. So the market undervalues it. The technology does its work in silence. And in American home building, silence is often mistaken for irrelevance. This is why the modern home improvement economy loves things that can be seen, touched, and branded. A smart thermostat feels modern. A new water heater feels like an upgrade. A solar panel feels like an energy statement. A bigger tankless system feels powerful. But a passive heat exchanger inside the plumbing system feels almost too plain. It has no app, no screen, no moving parts, no sound, no monthly dashboard. It simply sits there and transfers heat. That simplicity should be its strength. But in the marketplace, simplicity can become a weakness. Because simple things often create fewer reasons to sell service, replacement, and upgrades later. A water heater can fail. A compressor can fail. A control board can fail. A pump can fail. A drain water heat recovery unit has no motor to burn out and no refrigerant to leak. Natural resources. Canada describes the technology as simple, long-lasting, and having no moving parts. That is excellent for the homeowner. It is less exciting for a market built around replacement cycles. This does not require a conspiracy. It only requires incentives. The plumber installs what the plans call for. The builder chooses what the buyer understands. The supplier stocks what moves quickly. The inspector checks what the local code clearly recognizes. The homeowner upgrades what they can see. And the quiet copper pipe remains optional, unfamiliar, and easy to skip. Then there is the code and contractor problem. Drain water heat recovery deals with both wastewater and potable water. Even though the two streams do not mix, the system still sits at an important boundary inside the plumbing system. That means installation has to be done correctly. The heat exchanger has to be approved for the application. The plumbing arrangement has to meet local code. The potable water side has to be protected. The drainage system still has to drain properly. There can be pressure drop considerations. There can be clean out and access considerations. There can be local inspection requirements. And in many places, the safest answer is simple. Use a licensed plumber who understands both domestic water and drain waste vent systems. That makes sense, but it also makes the technology less casual. You cannot treat it like a countertop gadget. You cannot buy it, throw it under the sink, and expect it to perform. It has to be integrated into the house. And integration is exactly where American retrofits become expensive. This is why drain water heat recovery often makes the most sense during specific moments. New construction, a basement bathroom remodel, a major shower remodel, a water heater relocation, a plumbing stack replacement, a deep energy retrofit, a home with an accessible vertical drain from upstairs showers. These are moments when the walls, pipes, and mechanical spaces are already part of the project. The cost of access is lower. The design can be planned. The inspector can review it. The plumber can install it cleanly. But if the house is finished, the bathroom is on a slab, the drain runs horizontally, or the main stack is buried deep inside walls, the same technology may not make financial sense. That is the honest limitation. The device may be affordable. The installation may not be. And that is where internet hype usually goes wrong. It sees the price of the unit and ignores the cost of the house around it. A $300 pipe is only a $300 solution if the right pipe is already accessible. If walls have to be opened, drains rerouted, floors repaired, or plumbing redesigned, the economics can change. That does not make the technology fake. It makes it site-specific. And real building science is always site-specific. The same is true for performance. The system works best when warm wastewater and cold incoming water move at the same time. That is why showers are ideal. But if most hot water use in a home happens in short bursts, the benefit drops. If the incoming cold water is already relatively warm, the possible heat recovery is smaller. If the household uses very little hot water, the payback stretches. If the unit is undersized, poorly installed, or placed on the wrong drain, performance suffers. If the household has a low-flow shower, the energy use is already reduced, which can also affect payback. None of this ruins the idea. It simply puts boundaries around it. And boundaries are what make the claim trustworthy. This is not a miracle machine. It is a heat exchanger. It does one job. It takes heat from warm drain water and gives part of that heat to incoming cold water. When the conditions are right, that job can be valuable. When the conditions are wrong, the same device may sit there doing very little. That is why the real question is not, does drain water heat recovery work? The real question is, does your house give it the right opportunity to work? And this is where the technology becomes a perfect example of a larger problem in American homes. We often wait until energy has already been wasted, then buy a bigger machine to replace it, a bigger water heater, a faster recovery tank, a more powerful burner, a larger electric element, a more complex control system. But sometimes the smarter move is smaller. Recover the heat before it leaves. Preheat the water before the tank sees it. Reduce the lift before the heater has to make it. Make the existing machine work less instead of buying a larger machine to cover the waste. That is not glamorous, but it is elegant. And in a house, elegance often means solving the problem at the point where it begins. The shower drain is one of those points. It is where paid-for heat leaves the body of the home. It is where water that is no longer clean still carries energy that is not yet useless. It is where gravity, copper, and timing can quietly undo part of a mistake built into conventional plumbing. The tragedy is not that Americans do not care about saving energy. They do. They buy efficient appliances. They compare utility bills. They install LEDs. They worry about heating costs. They complain when the water heater cannot keep up. But most were never taught to see wastewater as an energy stream. The moment water crosses the drain, the mind classifies it as gone, dirty, finished, waste. But the heat inside that water has not disappeared yet. It is still there, moving, available for a few seconds, close enough to be captured. And in the right house, one copper pipe can take advantage of that narrow window. That is why this technology feels so strange. It does not create energy. It simply refuses to waste all of it. It does not ask the homeowner to shower less. It does not ask the family to sacrifice comfort. It does not ask the water heater to become futuristic. It only asks the plumbing system to stop letting warm water leave without giving something back. And once you see the shower this way, the bathroom changes. The drain is no longer just an exit. It becomes a missed opportunity, a small waterfall of paid-for heat, a quiet stream of energy leaving the home every morning. And somewhere behind the wall, if the plumbing allows it, there is room for a copper device that asks a brutally simple question. Why should the water heater pay full price for heat the house already bought? So, what does this mean for a real homeowner? It means the first step is not buying the pipe. The first step is finding out whether your house gives that pipe a fair chance to work. Start with the shower, not the kitchen sink, not the washing machine, not the dishwasher, the shower, because a shower creates the cleanest opportunity. Warm water is falling down the drain at the same time cold water is being pulled into the plumbing system. That simultaneous flow is what a simple, non-storage drain water heat recovery unit needs. If the warm drain water is leaving while cold water is entering, the heat exchanger has something useful to do. If those two events do not overlap, the opportunity becomes much smaller. Next, look at the plumbing path. The best situation is a shower drain that drops through a vertical stack into an accessible basement, crawl space, or mechanical room. That vertical section matters. Warm wastewater has to fall along the inside wall of the copper drain pipe. The incoming cold water has to wrap around it on the outside. If the drain run is mostly horizontal, buried inside a slab, hidden behind finished walls, or too short to provide useful contact time, the system may not make sense. This is where many houses are eliminated, not because the technology is fake, because the house was not built with this recovery path in mind. Then look at your household. A large family taking daily showers has a very different opportunity than one person taking short showers. A house with teenagers, guests, or back-to-back morning showers may send a lot of warm water down the drain. A small household using very little hot water may never recover enough heat to justify the installation. Cold climate homes can also have a stronger case because incoming water can be much colder. The colder the incoming water, the more work the water heater has to do, and the more useful preheating becomes. But in a warm climate where incoming water is already mild, the savings may be smaller. This is why the payback range is so wide. The pipe may be simple. The house is not. The people living in it are not. The climate is not. The plumbing is not. That is why a good plumber matters. A drain water heat recovery unit touches two important systems. The drain waste vent system, which carries wastewater out, and the potable water system, which carries clean water in. Those two streams do not mix inside a properly designed unit, but the installation still has to be correct. The drainage still has to flow properly. The clean water side still has to meet code. The unit has to be approved for the use. The connections have to be leak-free. The pressure drop has to be understood. Cleanouts, access, pipe sizing, and local inspection rules may matter. This is not the place for careless work. Do not cut into a drain stack because a video made the idea look easy. Do not modify potable water lines without understanding plumbing code. Do not bury a new connection where it cannot be inspected or repaired. And do not assume every local inspector will treat the installation the same way. Use a licensed plumber. Check local code. Check permit requirements. Check manufacturer instructions. And if the installation is part of a remodel, plan it before the walls close. That is the moment when this technology makes the most sense. New construction, a major bathroom remodel, a basement renovation, a water heater relocation, a plumbing stack replacement, a deep energy retrofit. Those are the moments when access is already part of the project. The walls may already be open. The drain stack may already be visible. The cold water lines may already be getting rerouted. The plumber may already be on site. That is when a few $100s of equipment has the best chance of staying a few $100s of equipment. But if you have to tear apart finished walls, move drains, open floors, repair tile, and rebuild plumbing just to install it, the economics can fall apart. That is not a failure of the physics. That is a failure of timing. The best energy upgrades are often the ones installed when the house is already being touched. This is the part homeowners have to remember. Drain water heat recovery is not a universal upgrade. It is an opportunity upgrade. If the shower is above an accessible vertical drain, if the household uses enough hot water, if the incoming water is cold enough, if the plumbing can be modified cleanly, if the local code allows it, if a qualified plumber can install it without turning the project into a major demolition job, then the pipe starts to make sense. But if those conditions are not there, forcing it into the house may not be worth it. That honesty matters because the goal is not to worship a copper pipe. The goal is to stop wasting heat where it is practical to recover it. And that idea is bigger than this one device. It is a different way of looking at the house. Modern homes are full of one-way energy streams. Heat leaves through uninsulated attics. Cool air leaks through gaps. Sunlight enters through unshaded glass. Warm water disappears into drains. And then we buy machines to replace what the building kept losing. A drain water heat recovery pipe challenges that habit. It asks the house to pause before throwing energy away. It looks at warm wastewater and says, "This is not finished yet." It still has something to give back. That is what makes the technology so elegant. It does not ask you to stop taking hot showers. It does not ask you to live uncomfortably. It does not ask the water heater to become futuristic. It only asks the plumbing to make one smarter exchange before the heat leaves forever. And once you see that, the shower drain changes. It is no longer just a hole in the floor. It is the exit point for energy you already paid for. Every morning, hot water falls into that drain. Every morning, cold water enters the house. And in most homes, those two streams pass each other without ever helping each other. The old house accepts the waste. The smarter house steals some of it back. That is the real lesson hidden inside this technology. The future of home efficiency is not always a giant machine. It is not always a rooftop array. It is not always a battery in the garage. Sometimes it is a quiet section of copper pipe hidden near the drain stack, doing one simple job year after year, taking heat from water you were about to throw away, and giving it back to the water heater before the bill gets bigger. So the next time you take a hot shower, listen to the water disappearing below your feet. That sound is not just water leaving, it is energy leaving, heat leaving, money leaving, and somewhere inside the walls of the right house, there may be a way to catch part of it before it is gone. If this video helped you see your home differently, subscribe to the channel for more forgotten building science, practical home technology, and simple physics modern housing often overlooks. And if you want more people to understand how much energy is hidden inside everyday household systems, hit the like button. Because sometimes the smartest upgrade is not the machine everyone can see. Sometimes it is the pipe nobody thought to ask about.